video clip explains how to use cosine and tangent in addition to sine. You can solve any of these triangles with sine because you know other angles and you sometimes there are more convenient ways to do it, and so we'll teach you cosine and tangent, just so you know what those relationships are. In practice, I always use sine just because I can always remember, but there is a mnemonic to remember cosine and tangent, and I will show that to you at the end. So cosine of theta is equal to the length of the side adjacent divided by the length of the hypotenuse. So instead of the opposite over the hypotenuse like sine was, it's adjacent over hypotenuse. So that way, like for our tree example, we don't have to change angles. We can stay with that same angle. But it's still a two-step process because we still have to solve for the hypotenuse first and then for the height of the tree. But let's go ahead and do some of those. So if we have a tree that's 100 feet away and we measure the angle to the top of the tree is 35 degrees, let's use cosine instead of sine. So the cosine of 35, theta in general, but 35 specifically here, is equal to the length of the side adjacent over the hypotenuse. Should we call it x? So solving for x, we'll multiply both sides by x. We're going to divide both sides by cosine of 35. So x is equal to 100 divided by the cosine of 35. Very similar on the calculator, like sine. So 100 divided by the cosine of 35 says that's 122 feet. Now we can use that same angle and we'll say that the sine of 35 equals the length of the side opposite over the hypotenuse, the length of the hypotenuse. So I just have to multiply each side by 122. 122 times the sine of 35. Really close to 70 feet. We're trying to find the height of a tree. 70 is good enough. So we used cosine to get the hypotenuse and then sine to get the height of the tree, so we never did have to get the other angle, but it's not that difficult to get, so we could have done it with sine, but just want to show you that cosine is the length of the side adjacent divided by the hypotenuse. Let's move to tangent. Tangent of theta is equal to the length of the side opposite over the length of the side adjacent. So there's no hypotenuse in that. So for this tree example, it works even better. So the tangent, well, let's go to an example. Opposite over adjacent. So the tangent of 45 degrees is equal to the length of the side adjacent over the length of the side length of the side opposite over adjacent. Opposite over adjacent. Opposite is the one we don't know, the height of the tree, and the adjacent is the 50. So this turns out to be a one-step problem if I use tangent. So h equals 50 times the tangent of 45. So on a calculator, we say uh, tangent of oops, ta tangent of 45 times 50. So tangent of 45. Oops. Tangent of 45 times 50 equals 50. In this case, and that's always the case with a 45-45 triangle. So maybe that just gives you confidence that it really works because we choose one that we know what it should be. So that's a single step process to getting the tangent. But remembering that it's opposite over adjacent, that may be another thing. So here's how you remember it. SOHCAHTOA. That says that sine is opposite. Just a sec. Gotta fix that. I'm gonna add an H. Is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA is how people remember which one is which. It's kind of a mnemonic, a way to remember it. Sounds like a Polynesian word, so it's easy to remember. Probably the cross-country runners would put that in their chant. Anyways, you can use sine, but there will be questions on the ACT that at least want you to know the ratio. They may not have you use a calculator, but they'll want you to use the ratios. So know what those ratios are.